Hello friends, welcome to Edwiki Learning channel. Please do subscribe to get more updates on the DevOps concepts. This video is part of the full course AWS DevOps Practitioner training. Please do check the description below to get the link for the complete full course. Without further delay, let's get into the video. Thank you.
I think I'll get start with this architecture. Okay, so in this architecture, right, the scheduler policy is the one who is responsible, or the scheduler policy, sorry, let me rephrase. The scheduler is the service that is running in the control plane node, which is now responsible to follow certain scheduling policies to decide your deployment. Your pod should be get deployed it into which worker node. I think I need to introduce one more terminology here, guys. The workload. Most of the folks may use the term called a workload. Workload in the sense your pod only, nothing much. Pod is very specific to Kubernetes terminology. A workload is very common general language. That's it. Both are same in a way. Like someone will may say you that hey, could you please deploy this workload into Kubernetes? What is workload? Your application is nothing but a workload. So that's just another synonym terminology that the people are using, right? That means what? Whenever you are expecting a workload to be running in a Kubernetes cluster, the scheduler is now playing the responsibility of deciding your workload should run in which worker node. By default, it follows certain scheduling policies. Most likely, by default, it follow which worker node has enough amount of processing and the memory capacity. Then it will try to schedule it over there based on the requirement. Are we good with the statement, guys? If that is the case, right? Of course, we don't need to worry about my application is running in which worker node, correct? The application may run in any worker node. I am able to access my application from outside world or maybe within the Kubernetes cluster as well, right? If the application has to be accessible within the Kubernetes cluster, then that will be accessible via the cluster IP service. If the application has to be accessible from outside of the Kubernetes cluster, that will be accessible via the ingress. Are we good with this statement? I'm keep on changing my delivery statements, right? As and when I'm introducing a more concepts based on that advanced concepts, right? I'm trying to reframe my statements as well, right? So now the thing is, I don't want my scheduler services following certain default scheduling policies. Maybe for some reason I wanted to enforce that my workload to be get deployed it into specific worker node. Getting me? Right? I don't want my workload is going and deploying it into a random worker node decided by my scheduler. I wanted to very specific about my workload where it has to be running. If I have multiple worker nodes in my cluster, I would like to tell that, hey, this workload should go to specific worker node. How do you enforce the scheduling policies of your scheduling service? That is what is the concept now, which is going to be little confusing, little tricky as well. But yeah, we'll try to make it little easier. But until unless you go back to this topic and try to do little research on your paper, so it will not be definitely easier to understand, guys. I would say rather you doing this on a lab practice, better to do some paperwork to understand it more easier, right? Of course, later we can go into some practices as well, right? So while I'm going through, if you have any specific questions, talk to me, guys, and let me try to introduce you. How do you enforce the scheduling policies? Okay. And first of all, why do you need to worry about your workload has to be run and which specific worker node, guys? The very biggest problem with the Kubernetes, right? The multiple logical groupings that we are doing. If you look at a high level, right? So sometime I have said that node group is the logical grouping of the multiple worker nodes. After that, I said that the namespace is the one which is the logical grouping of multiple pods, correct? So, uh, now I'm telling that, I need to deploy my workload it into specific servers, not for all the servers. How I'm going to do that specification again? There are multiple things are coming in. Let me get into one presentation. Hopefully this presentation is the right one to go about it for now. So in this presentation, I'm going to talk about a couple of technical terms like chains, tolerations, node selector, node name. I'm going to introduce all these different four terminologies, guys, which are actually helping us to enforce the scheduling policies, how you are expecting a pod has to be get scheduled on your worker node, not to go in a random selection. As part of this exercise, I have taken 5 worker nodes in my Kubernetes cluster, right? Let's say now I wanted to deploy my workload. I will use my kubectl command line utility and I will be connecting to my API server. I'll supply my deployment manifest file, right? Then I'm expecting my application to be get deployed. Now let's say the every worker node will have a name, guys. Following me, right? Every worker node will have a name which is called as a server name, correct? Which is called as a server name or your EC2 instance name in our case, right? Every server or every node will have a name. In this case, let's say worker one is the name of my first server, worker two is my name of the second server, worker three is my name of my third server, something like this. Every every system has its own name. So technically we call it as a host name, right? The host name is actually the name of your server. Good. Now usually, answer me, guys, as and when I'm keep on asking you some questions to understand this in a better way. Now, you go with the kubectl command and you deploy a deployment. Now, tell me, where do you think the pod will be get scheduled at this time? At this time, I don't have any custom scheduling policies, right? At this time, I don't have any custom scheduling policies. Let Kubernetes decides. So the scheduling service may schedule your pod anywhere at this time because you did not say anything. It will go in random. Try to pick the one whichever is feasible to run the application. Let's say it is deploying it into a worker one. Okay, that's fine, right? So now I wanted to enforce. No, I don't want it to be deployed in randomly in any one of the worker node, right? So in order to enforce the scheduling, right, you go with these taint, tolerations, node selector, and node name concept. Let's see how that is going to be working now. First, let me select the taint concept. Okay. So when I say taint, taint is one of the property or one of the configuration that you will be adding to a worker nodes. You see in this case, I'm applying a taint configuration to a worker node 3, and you see the taint value will be in this format. The key is equal to a value. The value will again be like this. Let's say a key colon again value. That's a standard syntax how a taint value is supposed to be. In this case, the taint value is name equal to app colon no schedule. That is the taint value that I'm using. Okay, so I'm giving this taint to my worker node. It is possible to give the taint to a worker node. I'll show you how to give the taint to a worker node. Let's say currently I have given this taint to the worker 3. Okay. Now, when you are deploying the application, right, right, in your manifest file, you need to add a toleration configuration. Always the taint configuration will be at a worker node side. Toleration configuration will be at your deployment side in your kind of deployment, right? In the deployment manifest file, you need to give this a toleration configuration. What is this taint and the toleration? Whenever you give a taint to a worker node, is mean that this worker node will be accepting the workloads, whichever the workload has a toleration matching the same taint value. Getting me this now? Now, if you see the scenario, in my deployment, I'm using a toleration. In the toleration configuration, key is name, the operator is equal to equal. That means what? The key is name, and if the value is app, the effect is no schedule. So which is equivalent to your taint value, right? If you see the taint value, key is name. What is the value of this key? The value is app colon the effect is no schedule, right? So the key and the value and the effect, all the three sections are actually matching with the toleration configuration that I have given in my deployment manifest file, correct? Now tell me guys, if I deploy this workload with the tolerations that I have specified here, what do you think? The pod will be get deployed in which worker node now with this toleration configuration if I add it in my deployment manifest file? Now, one thing to understand here, right, to make the things easier, right? Who has a constraint here? Who has a constraint here? That means who is actually deciding what to run? The worker node is deciding, or the deployment configuration is deciding? Who is deciding my pod should be get deployed where? Or who has a constraint here? Let's say the worker one. Do you see the worker one has any constraint? No. Worker 2 has any constraint? No. Worker 3 has a constraint? Yes. What kind of the constraint that the worker 3 has? Worker 3 is saying that, hey, I can accept a pod if the pod has a toleration matching with my taint configuration. Then only I can accept the pod, or else no. That is what the worker 3 has its own constraint. But do you think, is there any constraints from your deployment manifest file? That means in the deployment file, I'm adding the toleration, that is fine. But do you see any constraint in the deployment file saying that my pod should only be running in this worker node? Do you have that kind of the constraint added in a deployment file? No, right? I did not do that. The toleration is not a constraint. That means the toleration is not a condition that it has to go to this worker node only. No, that is not a condition. Just kind of a property. The constraint is at worker node 3. Now being said that, now what do you think? At this time, if I deploy my application having this toleration configuration, what do you think? The application will be get deployed where? The possibilities at least. The preference could be worker 3. The preference could be worker 3. But if I look at the possibilities, right, this application can go anywhere in all these five worker nodes. Agree with me? Right? This pod can go anywhere in all these five worker nodes. Because worker 1 will accept it, 2 will accept it, 3 also will accept it. Why? The 3 has a constraint, but my pod is already having that matching toleration, so it is satisfying the constraint. So the worker 3 also will accept this pod, so it can go anywhere. But you know, but worker 3 is like a preferable. Why? It has a specific constraint and I'm matching to that constraint only. The scheduler will try to put your pod it into worker 3 only as a preference only, but there is no guarantee that it can go to 3 only. It can go anywhere else as well at this time, because you don't have a constraint at a deployment side. Being said that, in the taint and the toleration concept, the taint is the constraint. That means the constraint is added at a worker node side, not at a deployment side. That's the first scenario. Are we good? Now let me go to the second scenario. Let's say out of these 5 worker nodes, for some reason the worker 3 is not available. Maybe assume like the worker 3 which has this taint constraint, right? This worker 3 for some reason got terminated. Maybe it is down, not available, whatever it is. It's not there now. It's not available in a way. When I say not available, the worker 3 might be a part of the cluster, that is still part of a cluster, but it is not accessible or it has some issues, right? Now, in this scenario, what do you think? The workload can be get deployed where? Again, kind of a same question, right? It can go anywhere, 1, 2, 4, 5. Again, just to repeat, right, as I see a question in the chart window, there is no constraint with the toleration. The constraint is only at a taint side. That means when I have a toleration configuration in my deployment file is not mean that your pod will go to only that specific. No, that's just a toleration configuration just to satisfy the worker node which has a taint. For that worker node to satisfy the configuration, I'm adding the toleration, but there is no rule that I'm forcing that, hey, you have to go to there only. No, right? So it can go to 1, 2, 4, 5 as well at this time. Now, let's say I have done the deployment, and as I said, right, the deployment can go to 1, 2, 4, 5. Assume the deployment is deployed it into worker 4, right? Let's say it is deployed it into worker 4. Good. Now what I'll do is, right, I will try to add a taint configuration on a worker 4 now. The taint is like a property. You can just run some kubectl command and just give this taint property to the worker node possible. Let's say for my worker 4, now I'm adding a taint. Okay, for my worker 4, now I'm adding a taint. Okay, if you see the taint here, name key is equal to value colon effect, name equal to app colon no execute. No execute is actually a effect. The effects are changing, guys. Okay, now what do you think? I mean to say, the pod is already running in the worker 4, right? The pod is already running in the worker 4. The time when the pod was deployed in the worker 4, that time there was no taint configuration on the worker 4, right? When the pod is deployed in the worker 4, that time your worker 4 does not have any taint configuration or does not have any constraint. Once it is deployed and once it is in a running state, right, now I'm applying the taint for that with the effect called no execute. Now what do you think? The pod, what is the toleration for my pod, guys, at the time of it was deployed as per this exercise? node schedule, right? So no schedule is the effect that I have added as a toleration for the pod that I was deployed. So now the pod is running in the worker 4. That pod toleration configuration effect is saying no schedule. But now in the worker 4, you added a taint after the pod is in running state, right? Now, do you think the pod will continue to be running in the worker 4 or not? Especially the question is the worker 4 taint is saying that no execute the effect. The pod toleration is not matching, right? Getting me? The pod toleration is not matching with the taint configuration of your worker 4. Now, what will happen to the pod that is running in the worker 4? Okay, if you understand the question now, right? So the first thing that we need to understand, because the pod toleration is not matching with the taint of a worker node, this pod should not be running in the worker 4, correct? Right? Because the moment when you give the taint to the worker node, the taint has a constraint. That means I can accept the pod, whichever the pod is having the matching toleration, then only I can accept the pod. That is what the worker node is saying, right? But in this case, your pod does not have a matching toleration. Both are different. Technically, the pod should not be running in the worker 4 because the matching is not there. The taint is different, the toleration is different. No, you should not run here. So the moment when you, of course, it was running before, that time there was no taint. Later you given the taint configuration by running some kubectl commands. So because the taint says no execute effect, the pod that is currently running in there, that will be get evicted. The evict in the sense the pod will be get moved from the worker 4. Why? It's not matching the taint. Second, the effect says no execute. That means no matter what was running before, no, don't keep any pods if the pods are not having the matching toleration. So those running pods also will be get affected. Those pods will be moving to different worker nodes wherever the possibility will be there. Are we good with this? Now let's say because my pod is got evicted because that is not matching the taint with the effect no execute. Let's say it is came to worker 2 now, because worker 3 is good. Worker 3 has a matching taint, but I said right, worker 3 is not available for whatever the reason, right? That's the reason your pod is now moved and it is came to worker 2 now. That is where it is scheduling the pod. Good. Now let me come to a scenario. So as I see a question in the chat window, right? At the time of the deployment, yes, the scheduler is responsible to check and try to deploy the pod in wherever the matching is there or possibility is there. That's true. But in this case, right, if I go back to my previous scenario one more time where my pod is currently running in the worker 4, right, and later you given the taint, right? So it's a, you know, it's the Kubernetes property, right? It's not about a scheduler, right? This is the Kubernetes property. It's a worker node property in a way, right? The worker node, which is a Kubernetes slave server, right? the worker node property not to accept this pod. That means, so in the worker 4, whatever is the services that are responsible, right, we'll try to ensure that it always check for the pods. If at all there is a taint, it check for the pod. Okay. The moment when you give the taint, it check for the pods. If the pods are not matching the taint, and if the taint effect is no execute, those will be get evicted. First of all, it will the worker 4 says that no, this pod should not be run here. You please go away. Once the pod is came out from the worker 4, it will come to a pending state now because it's not finding any other, right? Then the scheduler will come into the picture. Hey, you are in pending. Okay, let me see where I can find you. Then it will start searching for the possible worker and it will try to deploy it over there. That's how the whole process works here, right? That's how it is got evicted there. Once it is evicted, now the scheduler will try to find another worker node where the possibility, and let's say it is deployed it into worker 2. Now the another scenario, right? Let's say worker 1 is not available for some reason. Let's say worker 2 is also not available. Let's say worker 4 is also not available. In worker 5, I added one taint. As I said, right, the taint is always a constraint, right? It says that, hey, I can accept if you have the matching toleration. If you see the taint, of course, the taint is the constraint, but the effect is keep changing, guys, right? The effect is, one effect is no schedule, one effect is no execute, one effect is prefer no schedule. That is another effect. Only these are the 3 effects that are available in the taint. Now this is the current situation. Now tell me, guys, if I deploy a application having this so and so toleration that you see in the screen, what do you think? Your pod will be get deployed or not? If it gets deployed, where it will be get deployed? Of course, 1, 2, 3, 4 are not available, as I said, for some reasons. Only worker 5 is available. But do you think the taint and the tolerations are matching now in worker 5? It's not matching, right? The taint and the toleration are not matching. If you see, the effect is not matching there and there. Worker 5. 1, 2 are not available, as I said, right? 1, 2 are not available for some reason. Let's say worker 1 and worker 2 got terminated, restarted, whatever the reason. Now your pod will be get deployed in worker 5 only. Why? So the worker 5 has a taint, it has a constraint, that I agree. But if you see the constraint effect, the effect says prefer no schedule, in the sense, hey, I don't prefer the pods not matching the toleration. But if you don't have any other option, if you don't find any other worker node to deploy the pod, okay, you please execute on my worker node only. That is what is it mean by the prefer no schedule. Initially don't prefer, but if you don't have any other option, no other worker nodes are available to run the pod, okay, you please do this. That's how it will be accepted. That's the reason this time, though the pod toleration is not matching, but still it can be deployed it into worker 5 because it says a prefer only, not a hard rule here. This is just a soft rule. Are we good with this? Right. So it's very hard to do this lab practice, guys, but try to understand the concept because I'm giving multiple scenarios, right? Scenario 1, scenario 2, scenario 3. We can't go and execute all the scenarios one by one, how exactly it is working. It's very hard to reproduce these scenarios. Now, let me come to another scenario. Now, this is the situation. I have my all the worker nodes are good. As I see a chart window, right? If you give the no execute in worker 5 in a previous scenario, right? If the worker 5 has a no execute, your pod will never be get deployed. Your pod always will be in a pending state. Your scheduler keeps saying that, hey, I don't have a worker node to deploy, so it is in pending state. It won't be deployed because if the worker file has a no execute, I'm saying as per the question that I see in the chat window, right? So it won't be deployed. Okay. Now let me come to another scenario. The way how we can give a label for your deployment, you all know, right? We can give the label for all the Kubernetes resources. We can give the label for your replica set, can give the label for deployment, can give the label for pod, can give the label for ingress, can give the label for namespace. I mean to say what? The label is general concept which you can give for any Kubernetes resource. Even the worker nodes also considered as a Kubernetes resources only in a way. That means what? It is possible to give a labeling for your worker node also. Okay. And you see here, I'm giving a label for worker one. My label is key value pair, which is name colon app. I have a label for my worker node 2 as well. Just to reiterate, these are not a pod labels, guys. These are the label that I am giving for my worker node itself possible, right? My worker node, worker 1 has some label and worker 2 has a label, worker 3 has a label, worker 5 has a label, right? Now let's see another scenario. I'm done with my taint and the toleration concept. Now I'm moving ahead with one more concept. Okay, the taint and toleration concept is done. There are three type of taints. Taint effects are there: no execute, no schedule, prefer no schedule, and you just need to give the matching toleration there if you are expecting the worker node should accept only that kind of the parts only, right? So we have seen the difference between no schedule, prefer, and the no execute. Now if you have a labeling for your worker nodes, right, in your deployment manifest file, now each worker node has a name, has a label, both guys. Okay, worker node has a name as well as the you know one second. Yeah, so worker node has the labels, right? So I have given the label for 1, 2, 3, and 5. The worker 4 does not have any labels so far. Good. Looking at the chart window, right? Whatever I'm covering here are the Kubernetes concept, no AWS involvement here. All the labels that I talked about will be at a Kubernetes level only. These are not reflected, not visible at your AWS side. AWS tags are separate, which will be using by AWS. These are the labels using within the Kubernetes to identify the worker node to do the deployment process. Now, whenever your worker node has some labeling concept like this, right? In your deployment manifest file, you can add a property saying that node name is the key and value will be your name of your worker node. I mean to say your your name key value, right? Let's say here I'm using node name colon node 5 is the value that I given. That means, hey, my application should be get deployed it into the worker node, whichever the worker node has a name called node 5. That's what is the meaning of this key. Now tell me guys, now where do you think the pod will be get deployed now, right? This is very strictly hard rule. This is a strict hard rule. I'm specifically telling that, hey, this pod should go to worker 5 only. I mean to say, whichever the worker has a name called node 5, it has to go to that only. That's how you are strictly giving this information. Now that's one way of telling where the pod has to be get deployed. Now in this case, what do you think? The constraint is at a worker side or at a pod side or at a deployment side? That's important to understand. The constraint property is at a worker node side or at a deployment side. In the taint and toleration concept, right, the constraint is added at a worker node side. In the node name concept, the constraint is added at a deployment side. You are telling in the deployment manifest file that, hey, this pod must be going to node 5 only. That is the statement that you are telling at your deployment file itself, right? That means the constraint is added at a deployment file. Specifically, it has to go to the so and so node. Good. It is possible to add a one more property in the deployment manifest file saying that node selector. Node selector is the another property that you can add saying that what are the key value label that it has to use to select the worker node. And I'm using here node selector, and under the node selector I'm specifying a label or a key value pair label saying that, hey, go and search for the worker node. Whichever the worker node has a label called name colon app, you please deploy this application into that particular worker node only. That is what is it mean by the node selector. Now tell me, if you add a node selector as name colon app, what do you think? This application will be get deployed it into which worker nodes? The possible worker nodes now. Right? So don't worry about this node name that has to be disappeared. I'm not worrying about the node name that is already done. I discussed about the node name concept that is done. Okay, my animation is not removing that property. I'm only focusing on the node selector now. Okay, if I give the node selector, the node selector value is name colon app. What do you think? The pod will go to which worker node out of total 5 worker nodes that are available? So at least here, if I look through, right, name colon app is the label. Okay, that label is available on worker 1, worker 2, worker 3, correct? These are the three having this label. Worker 5 does not have the label. Worker 5 does not have the label called name colon app, right? Worker 5 has a label which is a different label altogether, which has name something something, right? So name colon app is the label that is on worker 1, worker 2 and worker 3 only, correct? So that means the possibility is your pod will be get deployed it into worker 1, worker 2 and worker 3. But again, worker 3 has a additional constraint called taint. So worker 3 says that, hey, I can accept a pod only if the pod has a matching a taint toleration, or else no, I'll not accept it. But in this case, I don't have any toleration in my configuration, at least in the presentation at this time. It has only the node selector. So worker 3 will not accept the pod because, hey, you don't have a toleration. So the only the possibility at this time is your application will be get deployed it into worker 1 and worker 2 only. Are we good with that? The 3 is not accepting. Why? It has additional taint as well. So it won't accept without having a matching toleration to your deployment file. So only 1 and 2 are the possibilities now where your application can be get deployed. Yes or no, guys? Let's say it is going for worker 1. So that's the concept of a taint, a tolerations, a node selector, and a node name concept. These are the three different ways how you can enforce your scheduling policies to decide your pod should go to which worker node exactly. Right? The node selector and the node name, if you look at the difference, right? Node name usually a unique queue, right? The name of the node will be a unique queue in your cluster. Let's say here I'm using node 5, right? You will not be having the same name given for a two worker nodes. Getting me? Every node will have their own name and the label both are different, guys. Okay, I'll show that difference later. The name and the label both are different. The name should be unique in a Kubernetes cluster. The labels can be the same. You see, the worker 1, worker 2 both are having the same label possible. So multiple worker nodes can have the same label, but you can't have the same name given for multiple worker nodes. Being said that, if you go for node name, definitely this is a hard rule that you are setting that this pod should go to this specific worker node. Only one worker node that you have specified, right? Because only one worker node will be there matching for the name that you given there. But if you go for the node selector, that is a label, right? Multiple nodes can have the same label and multiple nodes can be a possibility. Your pod can go to 1 or 2 as well, right? Because 1 and 2 both are matching the same label. That's how the difference comes in there. But the name will not be like this. Name is unique. Each node has their own particular name, right? No duplicate names given for multiple worker nodes anyway. So there is some other concept, guys. Let me try to bring it up. I don't know how it got missed out here. Give me a second. That's okay. So let me talk about this. On top of the scheduling policies that I talked about some time back, there is a concept of affinity and anti-affinity rules. Okay, this is a little more interesting, confusing as well. What is this affinity and anti-affinity concept? We'll see this. Let's say I'm taking just two worker nodes with me, right? And these two worker nodes has a labels. A worker node can have multiple labels as well. So why this label does not have enough data? right? So let's say I have two worker nodes, guys. So one worker node 1 and worker node 2, and I'm giving the labeling for the both worker nodes. Yes, you can give multiple labels as well. So one worker node 1 has a label called app. The value is Edwiki. Zone is one more key. Value is 1B. Worker node 2 has a two labels, app, web, and zone is 1A. So far so good. Interesting. So this is there. Never mind, I prepared the slide just now, so there is a small glitch. Okay, so the worker node 2 has an app, the value is a web. Okay, now in your deployment manifest file, right, the kind deployment, in the same manifest file, you can add a affinity rule. The affinity rule is a kind of a node selector only, right? And you see under the affinity, I am using the node affinity concept, right? The node affinity is exactly same as a node selector only, no difference. What was node selector, guys? Node selector is all about telling the deployment should go to which worker node by matching the labels, right? Whichever the node has a matching label, then your pod should go to that worker node. That is what is the node selector. The node affinity also the same meaning, but the extra specification that you get it here is you can add the how I mean to say the hard and the soft rules can be added to the node affinity. Here you see that under the node affinity I'm using the concept called required during scheduling, ignore during execution. Under that I'm using the node selector again because as I said, right, the node affinity is exactly like a node selector only but with a small change. And under that I'm actually giving the labeling concept. Key should be app, the value should be app, sorry, the value should be web, right? That is the label that I'm looking for. That means if the pod has to be get deployed, right, the label of the worker node should be app colon web, and which is a mandatory at the time of the scheduling. Now you tell me, guys, if I use this node affinity in my deployment manifest file, what do you think? The pod will go to which worker node at this time? One or two? Where the constraint is there? The constraint is given at a deployment side, and the pod will go to where? The pod will go to worker 2. Why worker 2? I said that the pod should go to a worker node, whichever is having the key as app, the value should be web, and which is a mandatory. That require during scheduling, ignore during execution. That tells that this rule is mandatory, is a must rule. You please select the node whichever is having this particular key value pair. Now your pod will go to worker 2 only, right? Now let's say this is the current scenario. Once the pod is deployed in the worker 2, it is currently running in. Now I'll go and change the label, right? I'll change the label from app equal to web, right? Now I'll change the label web, I'm removing and I'm giving a different label. Now what do you think? This pod will be running in the worker node or it will be get evicted, right? That's what is the discussion now. The node affinity, if you see the condition that I have given, right, required during scheduling, that means the initially when I'm trying to schedule a pod, I must be having the worker node must be having a label called app colon web. But once it is deployed, once it is running, later, if you change the labeling for any reason, don't care about it. That is what is called as a ignore during execution. So once it is deployed, later if you do any changes to the labels, though it is not matching, don't worry, let it continue to be running. That's how it is. Now your pod will continue to be running in the worker node 2 only, though the labels are not matching because you did the change later, not before the deployment. Now it did a small change now. You see under the node affinity, now I have added a statement called preferred during execution, preferred during scheduling, ignore during execution. There is a small change, guys. Now tell me, where do you think the pod will be get deployed? Sometime back the statement was required during scheduling. That is now got changed to preferred during scheduling. Where do you think the pod will be get deployed? Right? So technically, it will try to identify the worker node, right? It will try to identify the worker node, whichever the worker node has a label called app:web. That's the first preference. If it is not able to find that worker node with that labeling, then as a second preference, it can go to anywhere else as well. That's what is called as a preferred. Sometime back it was required, right? That is a mandatory. Now it is a preferred. So the preference is to go with the worker node if there is availability with the app:web. If not there, no problem. It can go anywhere else as well. Are we good with this? So more or less, the node affinity is kind of a node selector only, but you have got some option here to make it as a required or make it as a preferred. So based on the situation, you can do the things. Now come to a different scenario now. Now I'm talking about pod affinity. Sometime back I was talking about node affinity. Now this is a pod affinity. Okay, what is pod affinity? How that is working? In the pod affinity, we are using the concept called a topology key. Okay, we'll see how that works now. In the pod affinity as well, you can say that required during a scheduling, ignore during execution. That means when it is trying to deploy the pod, it must follow these conditions. That is what is called as a required during scheduling. What the condition says. In the pod affinity, the condition says that, hey, when you are trying to deploy the pod, you please check for the pods, you check for the existing pods. If any existing pods were there having a label called name:web app, and here we see the label selector and the match labels. What are these labels, guys? Is this the labels of a worker node or is this the labels of a pod? Right? These are the labels of the pod. Which pod? The one it is trying to deploy or the labels of existing pods? These are the labels of the existing pods. That means whenever you are trying to decide in which worker node you wanted to deploy, you first go and check if that worker node has already some existing pods with this label. If the worker node already having a pods with the label that is mentioned in the label selector, then you please prefer that. Let's say in this case, as an example now, at this present, whatever you see in the screen, now if I apply this pod affinity, what do you think, guys? Your pod will be get deployed in which worker node? Whatever you see on the screen based on this current situation, based on this current situation on the screen, right? Your pod will be get deployed it into which worker node? It won't be deployed in any worker node. Why? The condition is you check for the existing pod. If there are some existing pods with the label called name colon web app, then you prefer that. And in this case, I don't have any pods running with the same label, so it will not be selected anything. So your pod will not be get deployed now because it is not matching the existing pods with the label that you have been asked for. Now I'm done with that scenario. Now the second scenario. Now whatever you see on the screen, now tell me what do you think your application will be get deployed in which worker node, right? So first it will go and check for the existing pods in which worker node the existing pods were there with the matching label that you have been looking for, then it will go and select that one. Now in this case, your pod will be get deployed it into worker 2 because that is where it is already finding one of the pod running with the same label. But what is this topology key? Right? What is this topology key? Sometimes, right, there may be multiple worker nodes, right, having the similar labels. Let's say here worker 2 is there, right? Assume there is a worker 3. Assume there is a worker 3. Worker 3 also has a label called zone colon 1A. I don't have in the screen. Let's say worker 3 is there. Worker 3 has a label called zone colon 1A, right? Now what do you think? Your pod will be get deployed where? Worker 1, worker 2, worker 3. I have 3 worker nodes. The worker 3 is not in the screen, but assume there is a worker 3 which has a label called zone colon 1A, right? If you have a worker 3 with a zone colon 1A, then your pod can deploy in worker 2 or worker 3 also. That means topology key says that, hey, you first find the pod, you find the worker node where the existing pod having the same label. Okay, that's first thing. In this case, let's say it will go and identify worker 2. Worker 2, that is where the pod is already running. Now you pick up the topology key. What is my topology key? Zone. So it will check for the zone key and get that value. Then it will try to find, is there any other worker node having the zone colon 1A labeling? Then your pod may go to that worker node also, because your worker 2 labeling, the worker 3 labeling are now same, right? So it can go and pick up the other worker node as well wherever that topology key is matching. That's how the topology key concept will work here. Right, so need to visualize that worker 3 has a label called zone colon 1A, so that's not on the screen. Then because the worker 3 label is matching with the worker 2 label, then the pod can go to worker 3 as well, because you said topology key is zone. So that means get the zone key value from the worker node where you find the matching pod, then it can go into any of the worker nodes wherever the similar labeling is there. That's how it works. So covering the scenarios that you ask in the chart window is little tricky on the animation itself. Let's say I have worker 1, I have worker 2, I have worker 3, right? And this has zone colon 1A, this has zone colon 1A, this has zone colon 1B. Okay, so this is worker 1, this is let's say worker 2, this is let's say worker 3. Right now, let's say there is a pod that is currently running here. This pod has a label called app colon, right? Maybe name colon web app. That is the label of the pod. Now in the deployment side, right? In the deployment, you specify the right. You specify this pod anti-affinity. This is the syntax, right? You specify the pod anti-affinity, right? So in the pod anti-affinity, and of course you specify that required, sorry, pod affinity required during scheduling. You mention that, and this is the pod affinity. Okay. So now what will happen, guys? Where do you think the pod will be get scheduled? The first thing that it is going to check is there any worker node running the existing application with the label called name colon web app? That is the first check. Are we good with this first check? So it will go and check all the worker nodes, look for the existing pod, check for the existing pod is matching with this label or not. Once it identifies, let's say it is identifying that okay, in worker 3 there is a pod already running and the label is matching with the match label what you have specified. Okay, worker 3 is my preferable choice. The second thing, the topology key says that in the worker 3 which you have identified, you get the key called zone, you get the key called zone, and you see the value, right? You pick up this value, right? Take the zone as a key and right and pick up the value called value, whatever the value is there on that worker 3. Then you identify, is there any other worker node having the same key value pair? What is your key value pair of your worker node? Key should be zone. What should be the value now? Value should be 1A. Now it will go and search in the other worker nodes as well. Is there any other worker node having the worker node key as zone and the value should be 1A? And it identify that worker 2 is there with the zone is the key, value is 1A. So this value should be matching with the value of a worker 3 where the pod is currently running with this similar labeling concept. So this pod technically can go to worker 2 also. Right? Technically, this pod can go to worker 2 also. Of course, it can go to worker 3 also or can go to worker 2 also. Why it is going for worker 2? First, it is looking for worker 3 because that is where the existing pod is running. Good. Because you said topology key is zone. So on the worker 3 which is matching, it will get the zone key and the value, and then it will try to search for is there any other with the similar key value pair. Then it identified that worker 2 is there with the same key value pair. Okay, let me deploy here as well. That's how it works. Don't ask me the weight values at this time. This itself is little confusing, right? At least. Now Anyway, I'm here, right? Let me do a small change. In the pod affinity concept here, I can say that pod anti-affinity. I'm just giving a pod anti-affinity. If you give the pod anti-affinity, the concept will work in a opposite way. Now let me remove this arrow mark. Now, what do you think? Your application will be running in where? I just did a small change. I said pod anti-affinity here. That means, hey, the step number one, you look for the worker nodes where the existing pods were there with the label that I'm looking for. Then it identifies that worker 3 is available where the pods were existed already with the label that you have been asked for. Good. In the worker 3, get the topology key zone. Okay, let me take the zone key. Let me get the value. Now my key value is zone colon 1a. Then the meaning is whichever the worker nodes has zone colon 1a, don't schedule there. That is what is called as a anti-affinity. Try to find the one, then don't schedule there. So now your pod can go to worker 1 because here the key is different. It will not go to zone colon 1a because the topology key is zone, but you said anti, don't go there. So it will go to one worker 1 here in this case. That's how we can do a affinity rules as well to make it even more granular to decide your own scheduling policies. Yes, if you closely understand the concept, how this anti-affinity rule work, right? Sometimes, I don't want my two pods running in the same zone of EC2 servers, right? There are some hundreds of worker nodes. You need to understand, you need to tell that, hey, my application running with the two replicas, right? Replica 1, replica 2, both should not run in single zone. That is your requirement. Why? If both are running in the single zone, of course, two servers, but both are in the same 1A availability zone. If that zone is affected at AWS side, your both EC2 servers are gone, your both pods are gone, right? So you can tell that, hey, you go with the anti-affinity rule. So it will ensure that the two replicas, one replica will be 1A zone, the second replica will not go to 1A, it will go to another zone. If the zone is failure, you have a high availability. So that's where the use cases will come into the picture, and we will be using this in real time too. Lot of things here, and I'll just try to show you some configuration. Right, so I have two worker nodes with me, and you see the name. This is actually the name of the worker node, guys. This is the name of the worker node, which is the unique queue. And if you are using AWS EC2 instances, usually this name will be the same as what AWS is having. Okay, so kubectl describe a node and specify the node name. This is the command to see the more details about the node, right? In the describe, you see that your node is by default has some labels. Already the node has many labels. These labels are applied automatically by the Kubernetes. In these, one of the label that you see, topology.kubernetes.io/zone. This is the key, and the value is your availability zone. And you can see there is one label for region and there is a region as a value, instance type, so on, so on, so on, so on. And you can even see the host name, which is your node name itself. So these are the default keys, sorry, default labels. You can give your own label as well, right? So let's say kubectl label the node and specify the node name. This is the one, right? So kubectl, what will be the syntax, guys? Kubectl label a node, specify the node name. Let's say app colon web. I'll get the syntax. So it will be like a equal to, right? Kubectl label nodes and right. So now this node has a label that you have been asked for. If you look into the describe node one more time, you will be seeing a label called, you see app equal to web. This label is applied. Like that, you can give a label for your worker node, and then at the time of you doing the deployment, right, you define your pod should go to where. If I go to your deployment manifest file one more time, this is your deployment manifest file, right? In the deployment manifest file, why the replicas are taken out, right? In the deployment manifest file, under the spec section, right? Under the spec section, we need to tell node selector. I wanted to select a node, and what will be the key and what will be the value. Is that what I given? Yes. So this is how we need to give the labeling here. Then when you deploy this deployment, your scheduler policy will see the node selector. Okay, let me see the worker node, whichever is having this label. Your pod will go to that worker node only. That's how we use the node selector there. If you wanted to use the node name in the place of node selector, you can use the node name. What is your node name, guys? This is your node name, right? You see the name. This is the name in this case. So you specify the node name here. It's not a label, it's just a name. Now you see, in this case, your deployment will go to this particular node only, not anywhere else. That is what is the node name. So if you wanted to work with the taint and toleration concept, as always, the taint should be at a worker node side. The toleration should be at a deployment side, right? So you need to apply the taint for your worker node. kubectl taint, right? Node, specify the node, get nodes. First of all, let me see, is there any taint for this? kubectl describe the node, right? So the node name, labels, annotations. You see the taint section? Currently the taints are none, right? Now I can go and give the taint for this. Okay. This is the node name that I wanted to give the taint. kubectl taint the node, specify the node name. What is the format of the taint? It will be key equal to value colon and the effect. Let's say no schedule. I given a taint for my worker node. whatever the effect that you wanted to give, we can give there. Now if you do the describe, if it has a taint already, the existing taint will be get overwritten. Right now you see that it is added a taint. A node can have a multiple labels, but it can have only one taint. If already has a taint, it will be get overwritten, and there is a taint now. Now this node will accept the pods, whichever the pod has this matching toleration only. That's how it works. Now if you wanted to deploy the pod in this worker node, you need to use the matching toleration. So in your deployment manifest file, right, you need to add a toleration concept. And again, you need to get a syntax how to add a toleration in the deployment manifest file. See, we have multiple scheduling policies, right? We are not going to use all of them at one go, at one instance. You will not be using all of them in one single deployment file. No, based on the requirement, few people will be using node names, few guys will be using node selector, few people will be using node no sorry taint and toleration. Few times you may be using the affinity. So whichever you makes more comfortable based on the requirement, right, you will be using that. I have some examples already here, right? So somewhere you can see that here, this is how you need to add a toleration in your deployment manifest file. It will be under spec section. That's just a syntax that we can get it from documentation. So this is how we need to add here. The key should be app, the value should be web, effect should be no schedule, right? Just add it here, then this pod will be accepted by your worker node. That's how the taint and toleration concept works here. Same way, the affinity and anti-affinity rules also can be given. Kubernetes affinity and the anti-affinity rules. Somewhere you can see the syntax, right? You see, this is how you need to go. Under the spec, you need to give the node affinity and give the syntax. This is for preferred. And you can see example for pod affinity as well. This is the pod affinity and this is the pod anti-affinity. Just the same time syntax along with the topology key. We just need to add it over there. Some examples are given here, right? Just copy paste it and modify the values accordingly. That's how the whole custom scheduling concept will work. At the overall, right, why do we need to use these custom schedulings? The one reason, I don't want my two replicas should be running in the single worker node. I don't want my two replicas are running in a single availability zone. That's a major requirement why we need to tweak these scheduling policies, because by default Kubernetes won't do all this, right? It will go and apply wherever it wanted to. So this one reason to get better high availability. Right, and also, right, sometimes your worker node has a different capacity, right? We need to define always my pod should go to specific set of servers using the node selector labeling and all. So that's how it will be useful, guys. right? So as I said, right, so I think nothing that I can go on deploy and show it. It's just a matter of add a configuration and run deploy and see how it working. So I given almost 10 different scenarios, right? Maybe if you have time, you can just try to see all the different scenarios how it is working by reproducing that scenario, right? Good. A question for you at this time. Well, I think I see one interesting thing in the chart window, right? What is that interesting? It's a good point. In general, this is what it is, right? This is your Kubernetes whole architecture. How many nodes are there in my Kubernetes, guys, as per the current screen? Total 4, right? I have total 4 nodes. Of course, out of 4, one is control plane, remaining 3 are worker nodes. That's how it is currently, right? When you deploy any pod, okay, when you deploy any pod, why the pods are always coming to worker nodes only? Why can't the pod can be deployed it into control plane? It's not best practice. Ideally, it's not a best practice to run the pod in the worker in the control plane, because control plane is only for managing the Kubernetes services, not for running your application. That is true, but technically it can be run in in control plane also, but it's not a best practice. Why the scheduling is not by default considering the control plane? Yes, it has a taint. So by default, it will have a taint applied for the control plane server. So it will not accept any pods. So that's the reason none of the pods will not go to control plane node by default. Always it will try to see worker node side only. That's a good catch. Now, if I look into a kubectl get ns, guys, in order to see the namespaces, I think we already familiar about the namespace. Just to call out something, right? Anything that you are deploying in the Kubernetes cluster must be there in the namespace only. Even if you don't specify the namespace, by default that will be get deployed it into a default namespace only. Apart from that, you see some namespaces that are already created here. One of the important namespace is kube-system. Kube-system is a namespace that is created by default when you deploy the Kubernetes, and inside the kube-system namespace, right, there are certain applications are running. If you look into the pods that are currently running in the kube-system namespace, you see that it has some pods that are running, right, for your Kubernetes operational related, right? You see some services like kubeproxy, core DNS, AWS node. So these are certain Kubernetes related services. Those are actually management related, right? Do you think these applications are related to your business? No, right? This is not related to my web application, no, right? So anything that you are deploying the application that is required only for your Kubernetes administrative purpose, those will be running in the kube-system namespace, and these are few out of them, right? So in these are the defaults, guys. You are not deploying them. These are deployed running by default as part of the Kubernetes installation setup. In these AWS underscore node, this is the pod that is responsible to assign the IP addresses for every pod. Usually if you deploy the pod will get a IP, right? How would the pod will get a IP automatically? This is the service that is running in the kube system, which is responsible to give the networking IP assignment for every pod. Kube-proxy is one other service which is running, and it will be the responsible guy to give the network connectivity, like a port mapping, right? So previously it was a Docker proxy, now it is a kube proxy. If you closely look at more details, right, you see one kube proxy is running in one worker node, the another kube proxy is running in another worker node. Is it make sense, guys? In the Kubernetes architecture, I was calling out that the kube proxy is the service which will be running in the worker node side, which is responsible to give the networking connectivity of the pods and doing some port mappings and all, right? So it is running on that worker nodes by default. AWS underscore node, this is the another one which is running in both worker nodes. Why? This is responsible. The moment when the pod is deployed in the worker node, this is the service responsible to give some networking and give the IP and enable it. So that kind of the services are actually grouped into a kube-system namespace by default. Core DNS is the another service that will be running in the kube-system namespace, which is giving the internal DNS concept for you. I think we'll talk about that later, how that exactly works. That is what it is. Because I felt like I did not cover much about the kube system, so I just talked about it. So mostly anything that is very common application for maintenance per se, for administration per se, those will be in a kube system. That's how this is there. Now a general question for you at this time. Tell me guys, in general, if I ask you, hey, please go and deploy the application. I want to run my application in the Kubernetes cluster. What do you think? How many number of manifest files that you would need to deploy and run and access the application from outside world? Total, at least as of the discussion that I have, right? How many total manifest files that you would need to deploy and access the application from outside world? Of course, there are few one time, there are few keep on repeating. At least for now, I would say, right, I need a deployment manifest file, I need a service manifest file, I need a horizontal pod autoscaler manifest file, I need a ingress controller manifest file, I need a ingress manifest file to create an ingress resource. Maybe I need a name selector, sorry, namespace manifest file to create a namespace if that is very first time. Of course, you need a manifest file for the service accounts concept, role binding concept, lot many, right? The list is going and it will be increasing. Of course, out of these, like ingress control is one time only. The very first time that you deploy, later on maybe you don't need it in every application. But at least at bare minimum, right? If I talk about the repetitive application manifest files, can I call out like deployment, service, ingress, and horizontal pod autoscaler? Can I say these four at least are the mandatory for every application, right? These four are mandatory for every application. The remaining may be a one-time activity. Later on, you will not create all this again and again. So now the problem is how difficult it is for you to manage multiple manifest files, correct? You need to maintain HPA, ingress, and no, the deployment, a service, at least 4 manifest. If I go to the next level, you may be getting few more manifests as well in order to support multiple other features. So that is where now the people are feeling some difficulty in maintaining multiple manifest files. Now the second question that I wanted to ask you. Of course, I can manage the 4 manifest files. Let's say today I'm deploying my application it into dev environment. One manifest file to deploy the service in the dev. One manifest file to deploy my application. One manifest file to deploy the ingress to access the application on the specific URL. One manifest file for your horizontal pod autoscaler. Good. I deployed everything in the dev. Now I'll ask you, hey, can you deploy this it into QA? Can you use the same manifest file in the QA, guys? Of course, some things you need to visualize, right? We can't go into the implementation just like that. Can I use the same manifest files to deploy it into the QA? That's my question. Of course you can. Of course you can. It's just matter of right. It's just matter of giving right in your kubectl apply command. Let's say I'm trying to deploy the service, right? In this command, you just need to give -n and specify the namespace, correct? -n, specify the prod, -n, specify the dev. Like that, yes, you can use the same manifest file to deploy it into multiple environment, which is like multiple namespaces possible. But now my problem is, let's say when I am deploying the application, if I am deploying it into dev, please deploy with replica 1. When I'm deploying it into production, deploy with replica 3. When I'm deploying it into dev, I want the deployment to go with the memory 1 MB. If I'm deploying it into production, memory should be 1 GB. You know what I'm trying to? If you are using this manifest file as it is with the same configuration across all the environment, then there is no issue. I'll take the same file, I'll deploy it into dev namespace, then to the QA, then to the prod. No issue. The problem is application is same. Application is same. Maybe my image is also same because same code has to go into dev QA perf production, right? When I say same code, same application means same image. Your image might be the same, but sometimes the other deployment properties may change. Like I wanted to have a different processing capacity in dev and prod, different memory capacity in the dev and prod, right? And maybe I need a min and maximum scaling number should be different from dev and prod. Maybe my CPU threshold should be different from dev and prod. That means what? The configuration of your deployment will vary from environment to environment, though it is a single application. I mean, it is the same application. Agree with me, guys? If that is the case, now tell me how easy or difficult it is now to manage environment specific deployment. Now give me the answer. Can I use the same manifest file for deploying it into dev QA perf and production? I can't, right? I can't do that. Why? I can't keep on modifying the file. Let's say currently this file is written for dev purpose. Tomorrow if I ask you, hey, can you deploy this for QA? I can't go and change these values just like that. We need to maintain separate set of files, right? 4 files for dev, another 4 files for QA, another 4 files for production. Getting me? Like that, we need to make them separated files. Then only we can manage the stuff. That's very difficult to manage multiple manifest files, especially for the same application. What is the easiest way, guys? Go back to your timeline. Think of as a developer practice, always simple rule. The values should not be hard coded. Simple rule, right? Right? The values should not be hard coded. The thing is, because whether you deploy it into dev or QA or perf or production, do you think the left side variable is changing? No, right? The left side, whatever you see, that is pretty much constant. That is just a syntax, right? The left side, what you will see, that is a syntax. That is not changing. Only the right side values are keep changing based on the requirement. So that means when you are writing the manifest file, you write a manifest file in a generic way. Don't keep any values as a hard coded. You give the values as a variabilize. Then I can use the same manifest file in all the environment, and the values I can supply separately. Hey, these are the values for dev, these are the values for QA, these are the values for production. Your manifest file is same, but values we can give externally. That is the easiest solution to manage one single application to be get deployed it into multiple environments. Are we clear on this statement? But the problem is Kubernetes is not supporting for variabilizing a values in the manifest file. Kubernetes is not supporting to make your values as a variabilized. It's not supported as of today. So you can't directly go and tell that, hey, this is a variable. No, Kubernetes will not accept it. Kubernetes need a value as hard coded only. It cannot be a variabilize. That's not supported. Hence the reason, right, we are taking the help of one other third party open source software, one other third party, open source solution called as Helm. Helm, Helm. Helm is the a package manager for Kubernetes in the sense the Helm is the open source software which will be now helping us to make your values as variabilize. Officially, the Kubernetes is not supporting, but still we are able to make that happen with the help of the HELM tool. Where how the Helm works, how the Helm is doing this variabilization, though the Kubernetes is not supporting, we'll see that in tomorrow. But this is what the Helm introduction here. Why do we need a Helm? That is a major reason, right? The Helm, using the Helm, I can make the things variabilize, right? Whatever the values that you wanted to give, make it as a variabilize, supply the variabilization later, so that one single manifest file, we can deploy it into all the environment with the different values. The Helm will take care of that. Being said that, and of course, I'll talk about the Helm tomorrow only, but being said that, now tell me guys, now think from the real-time perspective. If I ask you, hey, I have one application, could you please deploy this it into Kubernetes? What is that you need now? Will you be deploying the manifest file now onwards? No. What do? You need to take the help of Helm to do the deployment. That's what I'm trying to. What Helm will do, right? You prepare a manifest file. Tomorrow I'll talk about in detail, right? So you see here in this slide, I have a deployment manifest file. I have a cluster IP service manifest file. Like that, you put all the manifest files, like HPA manifest file, service manifest file, maybe ingress manifest file, whatever you wanted to write. put all the manifest files, make them as a generic way, and supply the values, whatever you wanted to. The Helm will take this manifest file, apply the variabilization values there. Finally, the Helm is going to combine all of your Helm charts it into one single package called as a Helm chart. So here, let's say if you give some four manifest file, right? All the four manifest files will be packaged, will be zipped into one single file called .tgz. This .tgz file is having all the manifest files that you need, maybe 4 or 5 or 10, whatever it is, right? All the files are packaged it into one single file. Now, if I ask you, hey, please deploy my application in the Kubernetes, will you be using the manifest file to deploy, or will you be using the Helm chart to deploy? Getting me? You are using the Helm chart for deployment. What is Helm chart? The Helm chart is just a packaged version of your manifest file only, nothing much, right? It is just combining all of your manifest files it into one single file. Inside the file, you have all the files only. So now you just deploy this .tgz file into Kubernetes. This single .tgz file, which is called as a Helm artifact or Helm chart, right? This file is called as a Helm chart. This Helm chart has all the manifest files that you are looking for. Just combine them it into one single package for easy purpose. Now you just deploy this Helm chart that take care of deploying all of your manifest files and applications, variabilization, a lot more. So the final goal is I need to deploy a application using the Helm chart method. As of today, I'm deploying using my kubectl apply command and applying this manifest files directly, right? No, you are not doing that now. So you'll be doing all of that using the Helm chart method only. We'll see how to convert this Helm chart, how to convert this manifest files it into a Helm chart. Then we'll see how to deploy the Helm chart into Kubernetes. We'll see what advantages that the Helm chart is bringing. I already talked about the variabilization some time back, but yeah. Any questions, do let me know, or else we are good for today.